So today we are gonna be starting with states of matter AS level chemistry, and it's gonna be a fun topic to revise. Chemistry is fun, chemistry is love, and let's get started with this topic. So we're gonna do a bunch of past paper questions. We're gonna revise the concepts, and it's gonna be fun. So let's get started. And before starting any subject, I just advise one thing that really works, that write on the top that I love chemistry. And when you say this thing, I don't know, it's universe or something or energy, whatever, it really just feels like you love what you're doing. And when you like what you're doing, you do it good. And that's what I believe. So let's start with this thing and start with the chemistry past paper questions for states of matter. Which statement is correct? Okay, so we are looking for correct statements. Aluminum chloride has a giant ionic lattice with Al3 plus and Cl negative ions. Okay, so you should know that aluminum chloride is not a ionic compound. It's a simple covalent compound. So you should know that aluminum chloride has to be a covalent compound. And how does it form? You have one aluminum, you have three covalently bonded chlorines with it, something like this, and the bond angle is 120 degrees, and this is a trigonal planar molecule. So that's a covalent molecule. And why is it covalent? Since aluminum is a metal, so you might think that why is aluminum chloride a covalent? Because aluminum has a lower electronegativity value. And the electronegativity between aluminum and chlorine, the difference between the electronegativities is not very much. It's a small difference. That's why they form a covalent compound. Moving on, this one's incorrect. Okay, sodium chloride dissolves in water. Okay, why does sodium chloride dissolve in water? Sodium is a positive ion, chloride is a negative ion. It's a, this polarity, it's attracted. That's why it dissolves, forming hydrogen chloride and sodium hydroxide. Oh my god, that's completely incorrect. Because when sodium chloride is going to dissolve in water, you have NaCl, and you dissolve in it water, what's going to form? Na plus ions are going to form and Cl negative ions are going to form. So you're going to just dissociate the ions. The ions are just going to get dissociated. There's no alkali going to form or no hydrogen chloride going to form. So this is also incorrect. You're just dissolving a salt in water, and the pH of the solution is completely going to be 7, because that's going to be a neutral solution. You're just dissolving a salt. The covalent bonds in silicon chloride, okay, prevent it from reacting with water. I believe this question is more about periodicity than states of matter, more dealing with periodicity. So you should know that this statement is also incorrect. Why? Because silicon chloride, it reacts with water, and what it forms is, you should know this thing, you have silicon chloride and it's going to react with water. You add excess of water and what's going to form? Silicon dioxide plus HCl. Okay, so HCl is going to form, so this is going to be acidic. So that's incorrect. I believe if you guys know periodicity, then you should know this is incorrect. Okay, next part says, when phosphorus chloride is added to water, the resulting solution conducts electricity. Yeah, because when you add these chlorides to water, PCl5, what's gonna form? PCl5 added to water, the first thing you're gonna form is, there's gonna be HCl formed. Because what happens is that this chloride is basically attracted to the H of water. Water is an H, and this chloride is attracted to it. So you form HCl. And when you form HCl, the resulting solution has H plus ion and Cl negative ions. So this option is correct. Next question says that, okay, when an evacuated tube of the volume 400 cm cube is filled with a gas at 300 Kelvin temperature, you should know what are we dealing with. This is volume, this is temperature, this is pressure. The mass of the tube increases by 0.65 grams. Assume that the gas behaves as an ideal gas. What is the identity of the gas? Might seem confusing, might seem challenging to some of you guys, but it's actually very, very simple. You should just know a formula for ideal gas. If you have any ideal gas, it's gonna be one formula, which is PV equals to nRT. This is the ideal gas formula that you should know for all gases that behave ideally. What is P, what is V, what is N, what is R, what is T? I'm gonna tell all, don't worry. So P is gonna be your pressure, V is gonna be your volume, N is gonna be your number of moles of that gas, R is gonna be a general gas constant, and T is gonna be your temperature. Okay, so what you have in the question, we're given with the pressure, are we given with the volume? Yeah, this is the volume, this 400. We're given with the volume, we're not given with the moles, we're given with the general gas constant, that's always with us, and we're given with the temperature. So let's put in our values to find the value of N. That's going to be simple and easy. So the thing is that you can't take pressure in kilopascals. Okay, you have to take it in pascals. Your temperature should be in Kelvin. Your volume should be in meter cube, m cube. So just let's figure out that what do we have to do and plug in all the values in this equation. Okay, my pressure should be in pascals. So it's 101 into 10 raised to power 3 pascals multiplied by my volume. My volume is in cm cube. 400 cm cube, I have to convert it into dm cube. So first I'll multiply it by 10 raised to power negative 3. And now I have to convert this dm cube into my meter cube because my volume should be in meter cube. So I multiply it further by 10 raised to power negative 3. So in total, this becomes 10 raised to power negative 6, and this is my pressure. My volume in meter cube is gonna be 400 into 10 raised to power negative 6. Pressure ho gaya, we are done with the volume, equals to N I don't have, R is the general gas constant, that is 8 point something, and that's given, the value is given on your exam paper. You go to a A-level chemistry paper, and I don't think it's given for P1. Yeah, it is. So over here you have the general gas constant at the front, 8.31 kilojoules per mole. So it's gonna be 8.31 multiplied by your nRT, temperature is 300 Kelvin, and from here you just figure out the value of N. What do you do? 101 into 10 raised to power 3 multiplied by 400 into 10 raised to power negative 6 divided by 8.31 times 300 equals to your moles. So let's figure out your moles. In my calculator, what I get is 0.0162. So now these are my number of moles. Now I have my moles, I have my mass. Can't I find the MR? It's simple. MR equals to my mass, which is 0.65, divided by my moles, which is 0.0162. So our MR comes out to be 40.1. So which gas has a MR of 40? So for that we need to consult the periodic table. Let's check out. In the periodic table we need a MR of 40. Okay, so what's gonna be the gas? That's calcium is that gas which has an MR of 40. But since it can't be calcium, why it can't be calcium? Because we're only given with the noble gases. So let's figure out a gas that has an MR near calcium. So you should always know these tricks and tips to make your exam good. It's gonna be argon, which is 39.9, because if we round off 39.9, it's gonna become 40. So always use your brain. Argon. Next question says that at temperature to 2500 Kelvin, and pressure 101 into 10 raised to power negative 4 pascals, a sample of this much grams. Now you're going to see repetition. Again, now you're going to observe it for yourself that how repetitive these questions are, because examiner is like, he doesn't has a lot of content to ask you from, so he's going to repeat the questions. This amount of sulfur vapor has a volume of this. What is the molecular formula of this sulfur under these conditions? What do we have to do? We simply have to figure out again the moles. From moles we're going to figure out the MR, and then we have to check which MR matches with the correct description. So let's again do PV equals to nRT. Okay, what is P? We need P in pascals, which is 1 into 10 raised to power negative 4. What is V? V is simply, now we have in meter cube, we don't even need to convert. That's good for us, 2.08 into 10 raised to power 6 divided by this R and T are gonna move down here. R is 8.31, temperature is going to be 2500 kelvins, equals to your moles. So let me plug in these values into my calculator and give you the answer. Into negative 4 times 2.08 into 10 raised to power 6 upon 8.31 times 2500, and this gives me how many moles? 0.01 moles. Now I have my moles and I have my mass. What is the formula for MR? MR equals to my mass upon my moles. My mass is simply 0.321. My moles is simply 0.01. Let's find out what I get. So 0.321 divided by my answer. If you solve this with me, it comes out to be 32. And 32 is simply the MR of 1 sulfur. So it's going to be option number A. If you solve these questions with me, I tell you, I guarantee your A star. I guarantee it. If you solve it before me and then check out your answers, you're going to get an A star for sure. So I just want one thing, that you guys solve it. Because without practice, just seeing me is not gonna make you do it in exam. You have to practice it yourself. In an experiment, this much mole of propanol is burned completely in 12 dm cube of oxygen. Okay, that's the volume of oxygen you're using measured at room conditions. What is the final volume of gas measured at room conditions? Okay, so propanol is gonna be C3H5OH. This is propanol, right? And you add oxygen to it, and the products are going to be carbon dioxide and water. Okay, we know this. Now let's make a balanced equation. So we have 3 oxygens on this side. Let's put a 3 here. And now we have 6 hydrogens on this side. Let's put a 3 here. How many oxygens we have? 3 2s are 6 plus 3. These are 9 oxygens. So let's put a 4 here. 4 2 times 8 oxygens, and this one is the 9th one. So 9 oxygens here, 9 oxygens here. The equation is perfectly balanced. Now we have this much of propanol that is burned completely, and this much of oxygen. What is the final volume of gas? What is the final volume of gas measured at room temperatures? Now we are dealing with how many gases? What do you think? How many gases are we dealing with? We have carbon dioxide gas that's going to be produced. This water, since you are burning something, so this is also going to be produced as a gas because it's a exothermic reaction. So all the water that's going to be formed is going to be converted into gas. And then you have the leftover oxygen that might be present. So first, we know that for 1 mole of propanol, we need 4 moles of oxygen. So we know for one thing, that for 0.1 mole of propanol, I have 0.1 mole. How many moles of oxygen do I require? I need 0.4 moles of oxygen. I need 0.4 moles of oxygen. And the volume of 0.4 moles of oxygen is going to be 0.4 multiplied by 24. 0.4 times 24, and this gives me 9.6 dm cube. So this is the volume of oxygen that's going to be utilized. out of my 12 dm cube oxygen, this much oxygen is going to be used up. So how much oxygen is going to be left? 12 minus 9.6. So we have 2.4 dm cube of oxygen that's going to be in excess, that's going to be left. So we don't use it. Now we have to figure out how much volume these two gases are going to have. So look at the ratios again. I'd again ask you that in an equation, the most important thing is these ratios. Look, 1 mole of propanol forms 3 moles of carbon dioxide. Simple. So 0.1 moles would form how many moles of carbon dioxide? 0.3 moles. And 0.4 moles of hydrogen of water. So how much volume is 0.3 moles of carbon dioxide going to occupy? So we're going to write that volume of carbon dioxide is going to be 0.3 multiplied by 24, and the volume of our water is going to be 0.3 multiplied by 24. We simply multiply the moles with the volume of a gas, 1 mole of gas, and that gives us the volume. So 0.3 multiplied by 24, 7.2 plus 7.2. Okay, so this is going to be 7.2. 7.2, this is going to be 7.2. 7.2. Now I add the volume of all the gases that I have. 7.2 of this, 7.2 of water, and how much did I had left for oxygen? 2.4. So all the volume that's going to be formed at the end plus 2.4, I just add it all, plus 2.4, 16.8 dm cube. I get 16.8 dm cube as my answer. So it's going to be option number C. I hope you get it how I did this. Now we have the same question repeating. Moving on to this question. Nitrogen N2 and carbon monoxide CO both have MR of 28. So now why examiner has given us this thing is to make us realize that nitrogen and carbon monoxide, they have the same MR. That means their mass is similar. The boiling point of nitrogen is 77 Kelvin. It's 77 Kelvin. And for carbon monoxide, it is 82 Kelvin. Carbon monoxide, it is 82 Kelvin. What could be responsible for this difference in boiling points? Now we need to figure out one thing. That we know that boiling points are because of intermolecular forces. So now I'm going to list down all the intermolecular forces that I know. First force is my van der Waals force. Okay? Number 2 force that I know is going to be my permanent dipole force. Permanent dipole. And the third force that I know is my hydrogen bonding. These are the 3 types of intermolecular forces that I know. And this van der Waals is also called instantaneous dipole. Or you can say it induced dipole. Achha. Now I have to figure out that out of these 3 forces, which force is dominating or causing this difference in the melting and boiling points. So the first thing that I realize, I need to check the van der Waals first. For van der Waals, I know that van der Waals are because of electrons. Van der Waals are because of electrons. And over here, I need to check how many electrons in my nitrogen carbon monoxide. So nitrogen is N2. N2 means 1n=14 plus 14. I have 28 electrons in my nitrogen. So nitrogen has 14 plus 14, 28 electrons. And my carbon monoxide, carbon has how many electrons? Electrons, sorry. We're dealing with electrons, not the mass. 7 electrons plus 7 electrons. We have how many electrons here? 14 electrons. 7 for one nitrogen. The mass of nitrogen is 14. But atomic number is 7. For carbon monoxide, it's going to be 6 plus 8, which is again 14, I guess. 6 plus 8, again 14. So now they have the same number of electrons, and when two species have the same number of electrons, similar electron number means they are, what do we call them in chemistry? We call them isoelectronic. Means these two are isoelectronic, and when two species are isoelectronic, they have the same amount of van der Waals. So van der Waals forces, or the induced dipole, or the instantaneous dipole, or the London dispersion forces, these are all different name for the same force. They're going to be same for nitrogen and carbon monoxide. So now let's figure out permanent dipole. Now we know that nitrogen triple bonded to nitrogen. Is there any dipole? No. Whenever two similar atoms, these are two similar atoms are bonded to each other, there is no dipole. So there is no dipole here. This is completely neutral without any dipole or any any kind of electrons being pulled here or here. There's nothing. Now let's talking about carbon monoxide. This is carbon monoxide. Over here, you know that oxygen has a higher electronegativity value than carbon. So it's going to be a partial negative charge, and carbon is going to have a partial positive charge. And there's going to be a permanent dipole. There's going to be a permanent dipole towards oxygen. So there's going to be a permanent dipole like this towards oxygen. So now there is permanent dipole forces over here, partial negative, partial positive. And there is nothing to cancel out this permanent dipoles. It's going to remain there. So that's why. CO molecules have a permanent dipole. Yeah, that's correct. NO molecules are not polar. They are non-polar because two similar types of atoms are bonded. So it's going to be option number A. N2 has a sigma bond and pi bonding. CO is only sigma bonding. No, CO also has pi bonding. But this bonding has nothing to do with the melting and boiling points, because you need to realize one thing. When you're melting nitrogen, you don't break this bond. You're not breaking this bond. What you're just breaking is the intermolecular force of attraction between the two nitrogen molecules. These are two molecules. This is one molecule, this is the other molecule, and this is the attractive forces between them. So you're breaking the intermolecular forces, not this bond. That is why this bond is strong. Sigma, pi, whatever this bond is, doesn't matter, because we're not breaking it in melting nitrogen. Okay, explain which statement explains why Buckminster fluorine has a lower melting point than graphite. That's simple. Buckminster fluorine is a simple molecular structure, has the formula C60. It is a simple molecular structure, and you know that when something is simple molecular, it has intermolecular forces that are weak, whereas graphite has a proper giant covalent structure. Graphite is gonna be giant covalent, and what do you have to break if you need to melt graphite? You have to break the covalent bonds, which are going to be hard. But when you have to melt Buckminster fluorine, what do you have to break? You have to break the weak intermolecular forces, and since they're weak intermolecular forces, it's easy to break them. But over here you have to break the strong covalent bond. So that's why graphite is going to have a higher melting point. Okay, Buckminster fluorine exists as discrete molecules with weak intermolecular bonding. Yeah, that's correct. Graphite is partially ionic. No, the carbon-carbon bonds, we're not breaking the bonds. That's the one thing I like to tell you guys, that you are never breaking the bonds. You're not breaking the bonds when you're melting something. In simple molecular, you're not breaking the bonds. It's going to be option A. The mobile electrons in graphite means it has a metallic structure. Not at all. Okay. The temperature of a sample of an inert gas is increased. It's an inert gas, it's increased. What effect this have on the number of molecules with the most probable energy and on the number of molecules with high energy? So what do we have to do? Over here we have to draw a good curve. We have to draw a good curve like this of number of particles on are gonna be reaction kinetics. Remember the graph we used in reaction kinetics? They're gonna be number of particles on the y-axis, and on the x-axis you have energy. And how does this curve look like? It was something like this. And when you increase the temperature, when you increase the temperature, what happened was that your curved lowered. Firstly, the height decreased, this height decreased, and the second thing that happened was, apart from the height decreasing, one thing else, this part moved towards the right. So now we just have to explain this thing. Number of molecules with the most probable energy. Okay, first the number of molecules that had the most probable energy was this. Okay, this. And now the number of molecules that have the most probable energy, I'm showing it with a different color, are this. Okay, so you guys tell me one thing. Did the number of molecules with the most probable energy decreased? No. Before it was this part. Now the part is just shifted towards the right. But the part is still there. Do you get it? So the thing is that it didn't increase or decrease in a way that you think that the number of molecules decreased. What happened was that this part just shifted towards this, but there was one thing. This height difference. This height difference meant that now these many molecules from here basically moved here. Okay, the molecules moved here. So what happens was that this area got a little reduced because of this hump. This part is only missing. The top one, this top part moved here. So there was a little decrease. And number of molecules with higher energy, it's gonna increase because this part, ab jab dekho, I'm gonna try to explain this. This part basically moved here. Okay? This top part just moved here. So now the molecules with the higher energy on the energy axis, there are more molecules, but number of molecules with the most probable energy came down, and the number of molecules with higher energy increased. Because over here, now there are more molecules, but here there are less. So the just graph became like this. I wish you guys could get this. Acha. Moving on to the next question, which says a 200 cm cube sample of water has an amount of oxygen gas dissolved in it. The amount of oxygen gas has a volume of this when it is measured at this. The temperature is this. What is the concentration of the gas? Okay. So now it's simple. Look. PV equals to nRT. Find out the moles. Once you have the moles, divide it by the volume and you get the concentration. Simple and easy. So I don't think it requires any explanation. This is easy, it's repetitive. The only thing that I figured out was that you just have to convert this 35 into Kelvin by adding 273 to it. And this cm cube, amount of oxygen, has a volume of this. Okay, the cm cube has to be converted into meter cube. And now 200 meter, don't use this. This is the sample of water. You have to use this when you are calculating the moles. Moles ke liye you have to use this 200. But for PV equals to nRT to get the moles of oxygen gas, you have to use this volume and this formula right here. Okay, I hope you get it. But once you have the volume, now not the volume, sorry, once you have the moles, And now you're going to use the formula that moles equals to concentration into volume. And now for this volume you're going to use this 200. Why this 200? Because we're finding the concentration of the oxygen gas in water, and that is the volume of water. That's easy. And that's it for today's class. I hope you liked it. Do consider subscribing to the channel, and that's gonna mean a lot. Bye bye.